Hey guys, this looks like a fun one. We're given a circle with radius 1 and a regular hexagon. And it wants us to find the length of the sides of the regular hexagon. And I think we're supposed to assume that the circle is tangent here, here, and here. This is day 24 of the 2025 Advent calendar. And if you want to try this one, pause it right now because I'm going to solve it in 3, 2, 1. First, as we said, since it's a regular hexagon, all these sides are going to be the same length. So we can label them all with a question mark. And something else about regular hexagons, we know the interior angles of any regular hexagon. They're all equal to 120 degrees. And here's the formula for each interior angle of a regular polygon. It's 180 minus 360 over n, where n is the number of sides. So since our hexagon has 6 sides, it's going to be 180 minus 360 over 6, which is 180 minus 60, which is equal to 120. So each of these angles are equal to 120 degrees. And then from here, let's focus on this triangle right here. It is an isosceles triangle because we have this side equal to this side. In every isosceles triangle, the base angles are congruent. So this angle will be congruent to this angle. Since this is 120 degrees, that means each of these have to be 30 degrees because we need all three to add up to 180 degrees. The sum of the interior angles of a triangle is 180 degrees. And now let's bring everything back. This angle here is a linear pair with the 120 degrees. The two of them added together will make a line. That means they have to add to 180 degrees, which means this is 60 degrees. And let's zoom in on all this right here. Let's get rid of the angles and let's focus on these two tangent lines to this circle. There's two really cool things about intersecting tangent lines of circles. First, this is congruent to this. Here's the notes for that right here. And the other cool property is if you connect this vertex to the center of the circle, it always bisects the angle. And up here, we know that the entire angle is 60. That means that each of these are going to be 30. Let's draw this radius of the circle to this tangent point, and it's also going to equal 1. And then the radius of the circle going to the tangent point is always perpendicular to the tangent line. And now inside of this triangle, we have a 30, a 90, the last angle has to be a 60. And in every 30, 60, 90 triangle, the hypotenuse is always twice as long as the shortest side. So if this side opposite the 30 is equal to 1, the hypotenuse will be equal to 2. And that's the main reason I wanted this triangle. Let's clean things up a little bit. And then from here, we have another linear pair. Since this is 30, this whole thing is going to be equal to 150. And then from here, let's get rid of the 30. Let's move the 2 down here and focus on these two tangent lines. Once again, this is going to be congruent to this, and this will bisect the angle. Up here, we saw the angle was 30, so each of these angles are going to equal 15 degrees. And then from here, let's focus on this triangle. The interior angles of the triangle need to add to 180 degrees. Since this is 15 and this is 150, the last one would have to be 15 degrees. And then since the base angles match, that means we have another isosceles triangle. So this side is going to be congruent to this side. And that means our question mark is equal to 2. And that is the answer to our question. Question mark is equal to 2. Let's put a box around it. We could give it a label, but since the one doesn't have a label, we can just leave it labelless. How exciting. And here's the next puzzle. We're given two small rectangles. These two both have an area of 12 and they're congruent. And it wants to know what is the area of the large rectangle. I'm sure this is going to be a fun problem. How exciting.